In the database folder, open the sleep database file. Create an abstract class that extends room database. Annotate the class with the database annotation. This leaves us with an error because we have to declare the entities and version of the database. We pass both parameters to the database annotation. We have only one table, and so we supply the sleep night class. If you have more than one table, add them all to this list. The version starts at 1 because that's a great first version. Whenever you change the schema, you'll have to up the version number. If you forget to do that, your app will not work anymore. Export schema is true by default and saves the schema of the database to a folder. This provides you with a version history of your database, which can be very helpful for complex databases that change often. For this app, we don't need to do this, so we set it to false. So we've told the database what entity to use, and now we also need to tell it about the DAO associated with our entity so that we can interact with the database. We do this by declaring an abstract value of the type of our DAO, Sleep Database DAO. In this app, we only have one table and one DAO, but you can of course have multiple tables and multiple DAOs as well. Next, we define a companion object. The companion object allows clients to access the methods for creating or getting the database without instantiating the class. Since the only purpose of this class is to provide us with a database, there is no reason to ever instantiate it. Inside the companion object, we declare a private nullable variable for the database and initialize it to null. Instance will keep a reference to the database once we have one. This will help us avoid repeatedly opening connections to the database, which is expensive. What does it mean that the variable is annotated with volatile? This helps us make sure the value of instance is always up to date and the same to all execution threads. The value of a volatile variable will never be cached, and all writes and reads will be done to and from the main memory. It means that changes made by one thread to instance are visible to all other threads immediately, and we don't get a situation where, say, two threads each update the same entity in a cache, and now we have a problem. Continuing inside the companion object, next we define the getInstance method, which will return a reference to the sleep database. We are going to use a database builder, and it is going to require a context. So we need to pass that context in, and we want to return a sleep database. The error we see now is because we are not returning anything and are expected to. Inside getInstance, we need to add a synchronized block. Multiple threads can potentially ask for a database instance at the same time, leaving us with 2 instead of 1. This is not likely in this toy app, but for a more complex app, that is possible. Wrapping our code into synchronized means only one thread of execution at a time can enter this block of code, which makes sure the database only gets initialized once. We are going to talk about threading more later, and you can check the instructor notes for more information. And we need to pass ourselves into synchronized so that we have access to the context. Inside the synchronized block, next, we copy the current value of instance to a local variable. We want to take advantage of Kotlin's SmartCast to make sure we always return a sleep database, and SmartCast is only available to local variables, not class variables. And we can now return the instance. We can ignore the return type error. Right now we are returning null, but we won't ever once we are done. Now, after creating the local variable, but before the return, we can check if there is already a database. Inside the if statement, we need to create the database. We use Room's database builder for this. Let me drop in the code and then explain it. So we invoke Room's database builder. We supply the context that we passed in. Then we need to tell it which database to build, so we pass in a reference to the sleep database class, and we need to give the database a name. Our next step is about migration. Normally, we would have to provide a migration object with a migration strategy when we create the database. Migration means if we change the database schema, for example by changing the number or type of columns, we need a way to convert the existing tables and data into the new schema. A migration object is an object that defines how you take all rows with the old schema and convert them to rows in the new schema. Thus, if a user upgrades from one version of our app with one database schema to a newer version of the app with a newer database schema, their sleep data is not lost. Because we don't have users yet, and defining migrations goes beyond the scope of this lesson, instead of doing something smart, we just wipe and rebuild the database instead of migrating. You can learn more about migration with Room in the blog post linked in the instructor notes. As a final step, and to get rid of the errors, we can now build the database. Then we assign instance to the newly created database. We now have all the building blocks for working with our Room database. This code compiles and runs, but we have no way of telling if it actually works. So this is a good time to add some basic tests.